By early 1942, the United States needed an answer it did not yet know how to deliver. The question was not whether Japan could be reached. It was whether the limits everyone trusted were real. This channel examines World War II through moments where certainty collapses and decisions narrow. If you're new here, consider subscribing. Now, let's begin. In the months following December 1941, American planners confronted a strategic problem that seemed simple on the surface and immovable underneath. Japan had struck Pearl Harbor. The Pacific Fleet was damaged. American morale had been shaken. A response was required. Not eventually. Not symbolically. Soon. But by early 1942, the geography of the Pacific imposed its own verdict. Japan's home islands lay thousands of miles from the nearest American airfields. The U.S. Navy could strike with carrier aircraft, but those aircraft were designed for short-range operations. The U.S. Army Air Forces possessed medium bombers capable of meaningful payloads, but those aircraft required long runways, fixed bases, and logistical depth. The two systems did not overlap. Doctrine reflected this separation. Navy carriers projected power through specialized aircraft built for short takeoffs, arrested landings, and compact storage. Army bombers operated from land, supported by established supply chains and predictable infrastructure. Each service understood its role. Each trusted its limits. Those limits were reinforced by numbers. Aircraft performance manuals specified minimum takeoff distances under ideal conditions. A fully loaded North American B-25 Mitchell required well over 1,000 feet of runway to become airborne. Even stripped of non-essential equipment, it was still a medium bomber, not a carrier aircraft. The deck of an American aircraft carrier offered less than half that distance. By January 1942, the arithmetic appeared settled. Naval aviators trained to maximize lift over short distances, but their aircraft carried light payloads and limited fuel. Army pilots trained for range and stability, not abrupt departures from moving decks. Combining the two violated assumptions on both sides. It was not simply dangerous. It was structurally unsound. Strategists did not frame this as a debate. They treated it as a boundary. Carrier decks were for carrier aircraft. Medium bombers were for land bases. The boundary was enforced by engineering tables, training pipelines, and decades of accumulated experience. It was not emotional. It was procedural. Tokyo, therefore, remained out of reach. This assessment shaped early war planning. The United States would rebuild its fleet. It would expand industrial output. It would move methodically across the Pacific. Any direct strike against the Japanese home islands would wait until bases could be captured or constructed within range. That was how modern war functioned. Incrementally. Logistically. Predictably. Intelligence summaries from early 1942 reflect this thinking. They focused on Japanese defensive perimeters, carrier strength, and anticipated timelines. The idea of an immediate retaliatory strike on the homeland did not feature prominently. Not because it lacked appeal, but because it lacked feasibility. The assumption hardened quickly. Army Air Forces leadership understood bomber capabilities in terms of runway length, fuel consumption, and payload stability. Navy leadership understood carriers in terms of deck cycles, recovery operations, and aircraft handling limits. Each system optimized within its domain. Neither was designed to stretch into the other. In meetings, the problem resolved itself without argument. Medium bombers could not operate from carriers. Carrier aircraft could not reach Tokyo with meaningful effect. The conclusion required no dissent. This was not pessimism. It was professional confidence. The certainty extended beyond aircraft. It shaped expectations about risk. A carrier operating within bomber range of Japan would be exposed to overwhelming retaliation. A bomber launched without a guaranteed landing field would be lost. Planners did not need to imagine catastrophe. They could calculate it. Loss rates. Fuel exhaustion. Mechanical failure. Recovery impossibility. Each variable pointed in the same direction. By February 1942, the United States possessed the industrial capacity to fight a long war, but not the means to shorten it. Retaliation would come later, after preparation. That was the consensus. It was shared. It was rarely questioned. What made this certainty powerful was not stubbornness. It was coherence. Every chart aligned. Every manual agreed. Every training syllabus reinforced the same conclusion. The systems involved were functioning exactly as designed. They filtered out proposals that violated known limits. The idea of launching medium bombers from a carrier deck did not survive that filtering process. It was not rejected dramatically. It was never seriously admitted. On paper, the raid had already failed. By February 1942, the problem had been defined so thoroughly that it no longer looked like a problem at all. It looked like a boundary. Carrier decks were too short. Bombers were too heavy. Range could not be extended without bases. Bases could not be captured without time. The logic closed in on itself. It was inside that closed logic that James Doolittle entered the picture. Doolittle was not brought forward as a solution in the conventional sense. He was not selected to inspire confidence or to embody retaliation. According to staff records from early 1942, his name surfaced because he was regarded as unusually comfortable with technical limits. He had flown aircraft at the edge of their envelopes. He had broken speed records. He had written and taught aeronautical theory. He understood aircraft not as symbols, but as systems. That distinction mattered. Doolittle held a doctorate in aeronautical engineering from MIT, a credential that set him apart in a military culture still dominated by experiential authority rather than formal engineering analysis. He had spent years as a test pilot, evaluating performance data, stress tolerances, and failure modes. He was accustomed to questions that did not begin with "can we," but with "under what conditions." When the possibility of a retaliatory strike against Japan was raised, Doolittle did not begin by asking how to attack Tokyo. He began by asking which assumptions were being treated as fixed. The distinction was subtle, but decisive. Most planners framed the challenge as an operational impossibility. Medium bombers could not operate from carriers. Therefore, the mission could not exist. Doolittle reframed it as a feasibility problem composed of variables: weight, lift, wind, fuel consumption, runway length. Each could be altered, but not freely. Each adjustment would demand a trade-off. According to later accounts from officers involved in the planning process, Doolittle did not argue doctrine. He did not challenge authority directly. He asked for numbers. How much runway was truly required under worst-case conditions? How much weight could be removed without compromising structural integrity? What fuel reserves were assumed as mandatory rather than essential? How much airspeed could be gained before brake release if environmental conditions were leveraged rather than avoided? These were not rhetorical questions. They required recalculation. At this stage, skepticism remained widespread. Carrier captains understood deck operations intimately and were wary of introducing aircraft not designed for them. Army Air Forces officers understood bomber survivability and questioned the logic of launching aircraft with no clear recovery plan. The mission still appeared to violate every accepted principle of force preservation. What changed was not opinion. It was framing. Once the challenge was expressed in terms of engineering constraints rather than operational doctrine, it stopped being rejected outright. It began to be evaluated. That evaluation did not generate enthusiasm. It generated silence. Silence, in this context, was meaningful. Training manuals and performance charts were pulled. Takeoff distances were recalculated under non-standard conditions. Weight reduction scenarios were modeled. Fuel consumption curves were re-examined. According to post-war analysis, many of these exercises were conducted without any guarantee that the mission would proceed. They were undertaken because the questions had been asked seriously. The process revealed something uncomfortable. The original impossibility rested on conservative assumptions designed to preserve margin. Those margins were not laws of physics. They were safety buffers. Removing them did not make the mission safe. It made it barely possible. This realization did not produce agreement. It produced unease. A mission that depended on removing margin at every stage was not a mission that fit existing command culture. There would be no redundancy. No reserve. No recovery option once launched. Doolittle did not attempt to resolve that discomfort. He accepted it. In memoranda circulated during this period, the language remains procedural. There is no rhetoric. No appeal to morale. Only adjustments, recalculations, and acknowledgments of risk. The tone reflects an understanding that persuasion was not the objective. Verification was. By late February 1942, the mission had not yet been approved in final form. But it had crossed a threshold. It was no longer dismissed as impossible. It was regarded as dangerous, marginal, and dependent on flawless execution. That distinction mattered. The raid stopped being an idea that violated doctrine and became a calculation that consumed it. From that point forward, opposition shifted from categorical rejection to conditional acceptance. If certain variables could be controlled, the mission might proceed. If they could not, it would be abandoned. The door that closed in this act was not institutional resistance. It was certainty. From that point forward, the raid stopped being a proposal and became a calculation. By March 1942, the mission had advanced to a stage where optimism was no longer useful. What remained was reduction. The aircraft selected for the operation was the North American B-25 Mitchell. It was chosen not because it was ideal, but because it sat at the narrow intersection of payload, range, and structural resilience. It could carry bombs heavy enough to matter. It could fly far enough to reach Japan if handled correctly. And it could survive abuse that lighter aircraft could not. But in its standard configuration, it could not leave a carrier deck. The problem was no longer theoretical. It was physical. Weight translated directly into takeoff distance. Every unnecessary pound extended the runway that did not exist. According to engineering assessments conducted in early March 1942, a fully equipped B-25 exceeded safe carrier takeoff limits by a wide margin. No adjustment to pilot technique alone could compensate. The aircraft itself had to be redefined. What followed was not improvisation. It was systematic subtraction. Armor plating was removed. Non-essential instruments were stripped from cockpits. De-icing equipment was taken out. Radios were eliminated from all but the lead aircraft. Each removal was logged, measured, and weighed. The objective was not minimalism. It was threshold compliance. The most controversial decision concerned defensive armament. Standard doctrine treated tail guns as essential. Bomber survivability models assumed pursuit and interception. Removing defensive weapons violated those assumptions directly. But the mission profile altered the threat environment. Low-altitude ingress, surprise, and speed reduced the probability of tail interception. Takeoff failure, by contrast, was guaranteed if weight limits were not met. Doolittle evaluated the probabilities and made a decision that reflected the new hierarchy of risk. The tail guns were removed. In their place, wooden broom handles were painted black and mounted to resemble machine guns. The substitution was not intended to deceive Japanese fighters. It was meant to preserve crew confidence without adding weight. According to post-war pilot accounts, the gesture was acknowledged quietly. No one mistook it for protection. This was not bravado. It was acceptance. Each aircraft modification reduced safety margin in one domain to preserve feasibility in another. Radios were removed, knowing that loss of communication would isolate crews once airborne. Navigational redundancy was reduced. Emergency equipment was minimized. The aircraft were being optimized for a single, irreversible phase of flight. Takeoff. Training adjusted accordingly. Pilots practiced short field departures repeatedly, often under conditions that offered no recovery margin. Power application became precise. Brake release timing was rehearsed. Crews learned to trust airspeed indicators that would normally signal abort conditions. Observers noted the absence of debate during this phase. Decisions were recorded, not argued. Once a system was identified as expendable, it was removed. The process did not seek consensus. It sought compliance with physics. As modifications accumulated, the aircraft changed character. They no longer resembled standard bombers. They became transitional machines, built to cross a single boundary and accept whatever followed. By late March 1942, weight reduction targets had been met. Performance tests demonstrated that under ideal wind conditions, the aircraft could leave a carrier deck with meters to spare. The margin was measured, not guessed. That margin was thin. There would be no allowance for hesitation. No space for correction. The aircraft would either fly or fall. This reality reshaped crew expectations. Mission briefings focused on procedures, not outcomes. Contingencies were discussed in terms of fuel exhaustion and ditching locations, not return paths. According to later recollections, the absence of recovery planning was understood without being emphasized. Once launched, there would be no second phase. The door that closed in this act was survivability as traditionally defined. The aircraft were no longer designed to endure prolonged engagement. They were designed to clear a deck and remain airborne. After the last item was removed, there was nothing left to negotiate. By early April 1942, the aircraft could leave the deck. That achievement resolved one impossibility and exposed another. Range. The distance from the carrier launch point to Japan, and then onward toward potential recovery areas in China, exceeded the safe operating envelope of the B-25 under standard fuel consumption assumptions. Additional fuel tanks had already been installed. That solution was exhausted. The aircraft could carry no more weight. What remained was behavior. Fuel consumption was not a fixed quantity. It was the outcome of thousands of small decisions made every minute an engine ran. throttle setting, mixture control, altitude discipline, formation spacing, deviate once, and the arithmetic unraveled. This was the least visible part of the mission, and the most decisive. Army Air Force's doctrine emphasized power margins and engine safety. Pilots were trained to avoid lean mixtures except at altitude and under controlled conditions. Running engines too lean increased cylinder temperature, reduced lubrication margins, and raised the risk of detonation. Mechanical sympathy was part of survivability. For this mission, mechanical sympathy had to be redefined. Engineering analysis showed that if engines were operated at lower revolutions per minute, with carefully lean mixtures, fuel burn could be reduced enough to extend range to the absolute threshold required. The numbers worked, but barely. The operating envelope narrowed to a strip so thin that deviation would be fatal. This was not a setting pilots could use intermittently. It had to be sustained for hours. Training reflected that reality. Crews practiced flying at uncomfortable engine settings. Instrument readings that normally triggered corrective action were tolerated. Oil temperatures climbed. Engine sounds changed. Pilots learned to resist instinct. According to post-war training summaries, the emphasis was not on confidence, but on restraint. Power application became deliberate. Speed was treated as a liability. Formation discipline tightened to prevent unnecessary throttle adjustments. Every action was evaluated in terms of fuel penalty. This approach inverted conventional combat flying priorities. Aggression gave way to consistency. Precision replaced flexibility. Pilots were not asked to outperform their machines. They were asked not to exceed them. The engines themselves were modified to support this discipline. Carburetors were adjusted to allow more precise mixture control at low power settings. These modifications did not increase reliability. They reduced tolerance. If mishandled, engines could overheat or fail catastrophically. The safety buffer was removed intentionally. Doolittle understood the implication. According to later accounts, he emphasized procedure over reassurance. There were no promises that engines would hold. Only confirmation that calculations had been checked repeatedly. The fuel equation also reshaped navigation planning. Detours were eliminated. Altitude profiles were fixed. There would be no opportunity to reroute for weather avoidance without consequence. Fuel consumption charts governed decision-making in flight. Once airborne, fuel became the mission's governing authority. This constraint unified the crews. According to diaries written after the war, pilots described long stretches of flight marked by quiet monitoring rather than active maneuvering. The cockpit became a place of measurement. Hands rested. Instruments were watched. The enemy was distance. The door that closed in this act was flexibility. Once the aircraft left the deck, the fuel curve dictated every remaining decision. There would be no adjustment without cost, and no cost without consequence. From that moment on, distance was measured in restraint. By mid-April 1942, the mission had been reduced to what it could be, not what doctrine preferred it to be. The aircraft could launch. They could reach Japan. They could remain airborne long enough to escape. What remained was the question of delivery. American bombing doctrine in 1942 was built around precision. The centerpiece of that doctrine was the Norden bombsight, a device treated as both a technical marvel and a strategic equalizer. It promised accuracy from altitude, stability through automation, and repeatable results under controlled conditions. Crews were trained extensively to trust it. On paper, it represented certainty. The problem was altitude. The Doolittle Raid was not designed to approach Japan from high altitude. Surprise required low-level ingress. Weather conditions over the Pacific in April were unpredictable. Cloud cover was common. Anti-aircraft defenses around Japanese cities were untested but assumed to be reactive. The mission profile favored speed and concealment over optimal bombing geometry. Under those conditions, the Norden bombsight became a liability. At low altitude, its stabilizing assumptions failed. Airspeed variation, turbulence, and rapid approach compressed the bombing window to seconds. The device was also heavy, complex, and classified. Losing one intact over enemy territory carried intelligence risk that planners were unwilling to accept. According to planning notes from early April, the question was no longer how to bomb accurately, but how to bomb reliably. The answer was subtraction again. The Norden bombsight was removed. In its place, crews were issued a simplified aiming device often referred to informally as the Mark Twain sight. It was crude. A basic metal frame calibrated for fixed height, low altitude release. It offered no correction for wind drift or aircraft movement. It assumed a stable approach and disciplined execution. It weighed almost nothing. This decision marked another reversal of institutional logic. The most advanced bombing technology in the American arsenal was set aside in favor of a device that relied almost entirely on pilot judgment. Accuracy would be approximate. Results would vary. Damage would be uneven. But the mission's objective had shifted. Post-war analysis makes this clear. The raid was not expected to cripple Japanese industry. It was intended to demonstrate reach. To show that distance was not sanctuary. To disrupt assumptions rather than infrastructure. Under that definition, precision was secondary. What mattered instead was predictability. At low altitude, the bombing run would be brief, exposed, and unrecoverable. Crews would have seconds, not minutes, to identify a release point and commit. There would be no opportunity to circle, recalibrate, or abort without compromising fuel margins and escape routes. The conditions demanded a form of reliability that doctrine did not emphasize. According to training summaries prepared in early April 1942, crews were instructed to think of bombing not as an act of accuracy, but as a timing problem. Release was governed by airspeed, altitude, and visual alignment rather than calculation. Pilots were trained to fly straight longer than instinct suggested. Bombardiers were instructed to accept imperfect sight pictures without adjustment. This approach inverted years of professional conditioning. Bomber crews were accustomed to correcting error. Drift was compensated. Approach angles were refined. The Mark Twain sight offered none of that. It rewarded decisiveness over refinement. Once aligned, release had to follow immediately. Hesitation carried more penalty than inaccuracy. The shift affected crew dynamics inside the aircraft. Responsibility consolidated. The bombardier's role narrowed. The pilot's role expanded. Decision-making compressed into fewer seconds and fewer hands. According to later memoirs, this compression reduced discussion rather than increasing it. There was simply no room for it. Importantly, this recalibration extended to expectations of outcome. Mission planners did not attempt to predict damage with precision. Estimates were expressed as ranges. The emphasis in briefing documents was on sequence, not effect. Aircraft would arrive, release, and depart. What happened on the ground was secondary to the fact that it happened at all. This was not a lowering of standards. It was a redefinition of purpose. By the time the aircraft approached Japan, the raid had fully shed the requirement to prove technical superiority through accuracy. It sought instead to demonstrate reach through execution. Briefings reflected this recalibration. Crews were instructed on target types, not target points. Urban industrial zones, dockyards, and military facilities were identified broadly. The emphasis was on release timing and escape routing, not bomb pattern density. This was not resignation. It was alignment. The acceptance of imprecision extended beyond bombing. Crews were told to expect variability in outcomes. Some bombs would miss. Some aircraft might release early or late. The success of the mission would not be measured aircraft by aircraft. It would be measured collectively. According to later pilot memoirs, this adjustment removed a different kind of pressure. The responsibility to perform perfectly was replaced by the responsibility to perform consistently. No single crew carried the burden of decisive effect. Each was part of a demonstration. The door that closed in this act was the illusion of control. The mission no longer depended on technological certainty or exact outcomes. It depended on execution within narrowed constraints. By the time the aircraft approached Japan, success had already been redefined. The measure of success had already changed. On April 18, 1942, the final variable entered the equation. It was not mechanical. It was not procedural. It was environmental. In the early hours of that morning, the task force carrying the bombers was detected earlier than planned by a Japanese picket vessel. The contact report moved up the chain quickly. According to naval logs, the carrier group was still hundreds of miles farther from Japan than intended. The launch point had shifted, not by choice, but by exposure. This development did not create a new decision. It removed the last one. The bombers would launch immediately, or they would not launch at all. Weather conditions at sea were deteriorating. Wind speeds were high. The deck was pitching. Under normal circumstances, these were reasons to delay flight operations. Carrier doctrine treated strong winds and heavy seas as compounding risks. They complicated deck handling and reduced margins for error. In this case, the same conditions altered the physics of takeoff. Wind over the deck mattered more than deck length. Naval calculations show that a carrier steaming into a strong headwind effectively increased the airspeed of an aircraft before brake release. On that morning, the carrier's forward motion combined with natural wind to generate a significant airspeed advantage. The aircraft would begin their takeoff roll already closer to flying speed. This was not improvisation. It was arithmetic applied under pressure. Doolittle and the carrier's commanding officers reviewed the conditions quickly. According to later naval reports, there was no extended debate. The calculations had already been done months earlier as part of contingency planning. The numbers were unfavorable, but not prohibitive. The storm did not negate the margin. It consumed it. This distinction mattered. Had the margin been eliminated entirely, the launch would have been impossible. Had it remained generous, the decision would have been routine. Instead, the weather compressed conditions into a narrow band where success depended on discipline rather than confidence. Carrier crews understood this intuitively. Deck operations were conducted with minimal verbal exchange. Aircraft were positioned precisely. There was no effort to accelerate the sequence beyond what had been rehearsed. According to deck logs, the pace was deliberate, not hurried. Speed would not create margin. Only procedure could preserve it. For the pilots, the absence of abort options reshaped perception of risk. Normally, takeoff failures occurred within a framework that allowed correction. On April 18, 1942, that framework did not exist. Brake release marked a point of no return. Engine failure before liftoff would be fatal. Engine hesitation after liftoff would be equally so. This was understood without emphasis. Doolittle's own aircraft launched first. This was not symbolic. It was procedural. As mission commander, he needed to validate the takeoff conditions before committing the rest of the force. According to later accounts, his departure provided confirmation, not reassurance. The calculations had already allowed for success. The launch demonstrated that they had not been violated. As the remaining aircraft departed, the deck shortened with each launch. Wind conditions fluctuated. Spray moved across the bow. No corrections were made to procedure. Any deviation risked compounding error. Once airborne, there was no sense of relief recorded in crew accounts. The most dangerous phase had passed, but the most consequential remained ahead. Fuel, weather, and navigation would govern survival. The aircraft were flying forward through a sequence that could no longer be influenced from behind. The launches ended. The carrier turned away. From that moment on, the mission existed only in its execution. The mission unfolded largely as anticipated. The aircraft approached Japan at low altitude. Bombs were released using simplified sights. Anti-aircraft fire was sporadic. Fighter interception was limited by surprise and timing. Damage was uneven, but visible. What followed was loss. None of the aircraft returned to the carrier. Fuel limitations, altered launch distance, and weather made recovery impossible. Crews scattered toward China. Some crash-landed. Some ditched. Some were captured. Casualties occurred after the bombing phase, not during it. From a narrow operational perspective, the raid was costly. From a strategic perspective, it worked. Japanese leadership had believed the home islands were insulated by distance. That belief shaped defensive posture, resource allocation, and public messaging. The raid invalidated it. According to post-war Japanese accounts, the psychological impact outweighed the material damage. Air defenses were redeployed. Fighter units were pulled back. Strategic assumptions shifted. American leadership absorbed different lessons. The raid demonstrated that doctrine could be bent without breaking if assumptions were interrogated honestly. It showed that feasibility existed inside margins previously dismissed as unusable. It revealed that engineering judgment, applied methodically, could open options that planning doctrine closed. None of these lessons were comfortable. The raid did not succeed because it was daring. It succeeded because every illusion of safety was removed before execution began. What made it possible was not secrecy, or surprise, or courage alone. It was the willingness to treat limits as variables rather than verdicts, and to accept the consequences of narrowing choices fully. History later remembered the Doolittle Raid as a symbolic act. A boost to morale. A gesture of resolve. But its overlooked side was more instructive. It showed how wars are sometimes shaped not by force, but by those who understand where certainty ends and calculation begins. And by April 1942, that distinction had already changed the course of the Pacific War. If you've made it this far, you understand that history isn't decided in a single moment. It's shaped by timing, hesitation, and the decisions people make when options begin to close. If this perspective speaks to you, consider subscribing for future episodes. As the war itself would prove, once events are set in motion, they rarely wait for permission.